Welcome class 12 chemistry chapter unit 10 haloalkanes and haloarenes. Today we are going to deal with the one very important question which usually come in your board exam also. Which one of the following has the highest dipole moment? Dipole moment is nothing but we know that it is represented by a symbol called mu equal to nothing q into d. Now q is the charge separation, means oppositely charge of the two bonded atoms. One has to be electronegative, other one has to be electropositive in behavior. And d is nothing but the internuclear distance between the two atoms. One has to be electronegative, other has to be electropositive in character. Now today they have given two options, methyl fluoride and methyl chloride. Now we are going to compare who is having the highest dipole moment and why. See here, methyl, here carbon, in the case of both methyl fluoride and methyl chloride, carbon is tetrahedral, sp3 hybridized. Both the cases it is sp3 hybridized. sp3 means about bond angle is 109.23 minutes, right? See here, this one is a fluorine. But we know from our intermediate level that fluorine is more electronegative in character than chlorine, because down the group when you go for fluorine, these are our halogen group, fluorine, chlorine, bromine, iodine. Okay, the electronegativity character decreases, but we know that the atomic size increases. Atomic size is increases, and the maximum size that of the iodine, right? So here what happens, if you go about the dipole moment study, तो हम लोग को पता चलेंगे methyl fluoride should be having more dipole moment as compared to the methyl chloride, but it is just the opposite. Why you know that? Because here the atomic size of fluorine is smallest, yes, smallest as compared to chlorine. So what happens, you know, the bonding here between the fluorine and carbon, they're having the dipole moment. This, first of all, let me write the dipole moment here, this one. So here if you compare just this one, carbon and fluorine, what we found, that the dipole moment is shifting towards, charge is shifting towards fluorine, because fluorine is highly electronegative than carbon. Chlorine also same way, it is having more electronegative character than electropositive character carbon. So it tries to pull the electron. That is the vector sign we have shown it here. It tries to draw the density. But here what happens, you know that here is the atomic radii is very small. See here, fluorine atomic radii or atomic size is very small as compared to the chlorine is having quite larger than the atom, quite larger atomic radii than that of the fluorine. Chlorine is having quite larger atomic size than that of the fluorine atom. So what happens here, the bonding which is going to form, here the bonding which is going to form like this one. This is the atomic radii of carbon and this is the fluorine, right? So this is the fluorine. When it bonded to hydrogen also very small, but we are not dealing with the hydrogen, we will deal only with comparing with this one. So here the fluorine and carbon, here the internuclear distance is very small. Internuclear distance small means here the bond distance or bond length is very small, is very small, right? Now when you compare to the chlorine, chlorine is having larger atomic radii as comparison to the fluorine. This one is a chlorine, so Cl, I write Cl, and this is nothing but hydrogen, right? And this is the chlorine. So because of the larger atomic size of the chlorine, the bond length increases. Here what? Here bond length increases. Here the bond length of CCl is larger than that of CF. So here the dipole moment, both of them are having the dipole moment, no doubt. Both of them are having the dipole moment, means it is not equal to 0. But methyl chloride is having higher degree of or more dipole moment than fluorine. Finish. Now the factor here, you know that because of the larger atomic size, that's why the bond length increases. Because of the atomic size is smaller, the bond length is small or decreases. Here is the larger. So here is the opposite. This should be more. This should be having methyl chloride is having more dipole moment than that of the methyl fluoride. Okay, then till then, good. Those who are listening me for the last copy it here, methyl chloride, because of the larger atomic size of the chlorine, it is having maximum dipole moment, and the fluorine, which is having the smaller atomic radii, it is having smaller bond length. Smaller bond length means smaller dipole moment. Larger bond length means larger dipole moment. Okay, then those who are following me for the last few months and all, please subscribe my channel as ever. And those who are newcomers, welcome to my lecture, Dr. Qureshi. And please try to bell the icons and press the like buttons and share with your friends, classmates, and near and dear ones for a better conceptual lecture. Thank you.